ठीक है, चलो कोई बात. Okay. So Apurva and Tanmay have come to the college and they have talked about Web3. Nayan is a negative infinity. Awesome. Okay. ठीक है. आज का टॉपिक थोड़ा सा डिटेल्ड रहेगा. मैं कंसेंसस के बारे में बात करने वाला हूँ. कंसेंसस मैकेनिज्म्स जितने लोगों ने सुना है इसके पहले, अगर नहीं सुना है तो आज सुन लेंगे. काफी इंटरेस्टिंग टॉपिक है और मजा आएगा. But anyway, before we start, we have another 5-10 minutes before we start. अगर आप लोगों को बातें करनी है, just raise your hand. Put in the chat what you want to talk about, and I'll give you the permission. We can talk before we start the session. अगर कोई सवाल है, if there's something, some technology, some fundamental knowledge जो आपने blockchain 101 में सीखा था जो समझ में नहीं आया था, आप लोग उसको भी डाल सकते हो chat में. I'll try to cover that as well. Let's make this more interactive, guys. Okay? कुछ set agenda से सीखने को मजा नहीं आता. Okay, I see a question. Sir, it's free. क्या फ्री है भाई? तेरे से पैसे नहीं ले रहा मैं. Okay, let me just quickly access my slide. Okay, Devansh, let me know when we can start. So, okay. You can see the number of participants in a panelist, right? Good. Okay, so after the blockchain 101 sessions, guys, on a scale of 1 to 10, how confident are you with your fundamentals? बता दो जरा. कितने कितने लोग हैं यहाँ पे जो अच्छा खासा नॉलेज जानते हैं, अभी ब्लॉकचेन 101 तो जानते हैं, सो दैट ये आगे वाला समझने को इजी हो जाए, नहीं तो आगे वाला समझेगा ही नहीं. ओके. 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 गाइस, कीप द चैट एक्टिव. ओके, अगर आपको कुछ भी लगता है, कुछ भी सवाल है, चैट में डालते रहो. एंड इफ यू गाइस आर ओके विथ मी टॉकिंग इन इंग्लिश एंड हिंदी, इफ यू वांट टू स्विच इट अप ओनली इन इंग्लिश, I can do that as well. But if you are comfortable in English and Hindi mix, so I can continue with this. Let me know in the chat. Okay. Okay. I'll continue in English only. Yeah, I know you guys are like used to attending college online lectures that are usually like only online, and there's a professor that comes, that teaches, that takes their attendance, and then you let them go. Please make sure that you don't keep this session in that way. This is a learning session, so if you have any doubts in your mind, if you have any questions, if you just feel that blockchain is all a sham, just put it in the chat section, and maybe we can have a conversation about it. Because if you don't learn something out of this session, I think both of us have wasted our weekends. So if we want to gain value out of this, make sure that you ask the right questions. Raise your hands if you want to talk to me, raise or put it in the Q&A section as an anonymous question. That is also allowed. But try to get most value out of this session so that you feel at the end of the hour, you've not wasted your time. Good. I'll quickly present my screen. Yeah. I'll keep an eye on the chat as well. And if you guys have anything, let me know. Okay. Devan, could we start? Awesome. Absolutely. Go ahead. I'll start the recording. Hold on.
Recording in progress.
Go ahead. Thank you for that lovely introduction. Let's start. Devang sir, let's go. Okay, so who am I? I am Nikhil Aparajit. I am the community lead at Lumos Labs. I am essentially the one responsible for taking care of all the community programs, some of the DevRel programs that our company runs. My job on a day-to-day basis is interacting with wonderful people, developers like you, wonderful students of engineering and science like you, and talking to them about blockchain, telling them about the world of blockchain and Web3 and decentralization, creating developer communities, just like the one Devansh is handling in his own college. That's my job. And it's pretty fun. And today I'm going to talk to you about the fundamentals of Web3, some of the one of the most important topics when it comes to Web3, that is consensus. So usually when I do into the Web3 metaverse, I cover like a plethora of topics, a lot of topics that I take care of. But this time I'm going to stick to one topic, and that is consensus. Sorry, which is a very important topic. If you have to understand blockchain and if you don't understand consensus, I think you're missing out on a lot, because that is one of the most important topic in Web3. So we're going to cover that, but before that, let's have a quick refresher. जिनके लिए जो लास्ट टाइम नहीं आए थे या थोड़े बहुत डाउट्स है उनके लिए. So what is blockchain? Blockchain is a way of storing information, a way of storing digital information. So just like how we store information in traditional databases in the form of rows and columns, in a blockchain, we store that information in the form of blocks. And every block is interconnected with each other. Every block is interconnected with each other by the virtue of hashing. And this is something that we are going to cover extensively in a demonstration that I'll show you what exactly I mean by that. But here's what you have to understand. Blockchain is a form of database. It's a form of like storing digital information. I think someone raised their hand. Okay. If you, Devansh, just keep an eye on the attendees if someone raises hand. Okay? If they have a question, I'll just quickly give them the access. They can ask the question. Okay. Okay. So here's what you have to understand about blockchain. Blockchain is a database. It's a way of storing digital information in a decentralized fashion. Now, how does it do it and what happens exactly at the back of it? We'll understand in a bit. But this is what the technology is all about. Now, this Web 3.0 that we usually talk about is the internet that is built on top of this blockchain technology. I think this far we have learned. Now, the most common use case of a blockchain, like the blockchain technology, is cryptocurrency. What is cryptocurrency? Cryptocurrency is a decentralized version of our finance. Now, when we have traditional currency like Indian rupee or US dollar, that currency's value is determined by the Indian government and the Reserve Bank of India. Indian rupee, for example, is governed by the Indian government and the Reserve Bank of India, right? How much is the value of one Indian rupee is determined by international currency exchanges, the amount of gold reserves that a country has, the amount of forex reserve a country has. Based on that and multiple other factors, the rate or the value of Indian currency is determined. Right? It's a very centralized system. Now, cryptocurrency, most specifically, Bitcoin is one of the most easily recognizable example of cryptocurrencies. This form of digital currency is a decentralized form of currency. What do I mean by that? Well, जैसे मैंने बताया कि इंडियन रूपी की वैल्यू इंडियन सरकार तय करती है, बिटकॉइन की वैल्यू बिटकॉइन का नेटवर्क ही तय करता है, एंड बिटकॉइन का नेटवर्क इज नॉट ओन्ड बाय एनी सिंगल इंडिविजुअल, राइट? बिटकॉइन की स्टोरी जिनको पता है उनको मालूम है कि बिटकॉइन को बनाया था एक अनजान शख्स ने या कुछ लोगों ने. द नेम ऑफ दैट इंडिविजुअल वाज सातोशी नाकामोटो. नाउ सातोशी नाकामोटो मेड दिस thing called blockchain. He published a white paper, he published a website about this technology called as blockchain. Nobody knows who Satoshi Nakamoto is, right? But the way Bitcoin has been made, we don't even need to know, right? The way Bitcoin is built signifies that this currency is a digital form of currency where I can share value from one individual to the other without having a central authority looming over me. मतलब मुझे अगर देवांश को 0.1 BTC भेजना है, so I do not need a traditional centralized banking server to govern the transaction. कैसे इसका एग्जांपल कैसे समझेंगे? इफ आई हैव टू सेंड देवांश 100 रुपीज ऑन यूपीआई फॉर एग्जांपल, तो चैट में मुझे बताओ कितने लोग इन्वॉल्व होते हैं इस ट्रांजैक्शन में, कितनी पार्टीज इन्वॉल्व होती हैं? कैन यू गेस इन द चैट गाइस? कैन यू गेस कितने लोग इन्वॉल्व होते होंगे अगर मुझे एक यूपीआई ट्रांजैक्शन करना है, 100 रुपए भेजने मुझे देवांश को? ओके, यश ने बोला है 2, एनीबॉडी? 3, 3, गुड गेस, गुड गेस, 3, 4, ठीक है, ये भी अच्छा गेस है, 3। ओके, मैक्सिमम कंसेंसस है 3 और 4 में। वेल, टोटल 6 पार्टीज इन्वॉल्व होते हैं। अब मैं बताता हूं कैसे। मैं और देवांश 2 पार्टी, मेरी बैंक और देवांश की बैंक 2 और पार्टी, और एनपीसीआई, नेशनल पेमेंट्स क्या नाम है, सॉरी, नेशनल पेमेंट्स कॉर्पोरेशन ऑफ इंडिया, सॉरी, नेशनल पेमेंट्स कॉर्पोरेशन ऑफ इंडिया, एनपीसीआई। तो 6 पार्टीज है टोटल। मैं और देवांश, मेरा पैसा है जो मुझे देवांश को भेजना है, मेरी बैंक, जिस बैंक से मैं पैसा उठा के इसको देने वाला हूं, उसकी बैंक में। तो ये 4 पार्टीज हो गई जो लॉजिकल सेंस बनाती है। अब इस बैंकिंग ट्रांजैक्शन को फैसिलिटेट करने का काम करती है आरबीआई, सॉरी, इसको वैलिडेट करने का काम करती है आरबीआई। मतलब ये ट्रांजैक्शन एक्चुअल में हुआ है कि नहीं, ये काम आरबीआई का है। नाउ इस ट्रांजैक्शन को फैसिलिटेट करने के लिए जो इंफ्रास्ट्रक्चर यूज होता है वो किसका यूज होता है? एनपीसीआई का यूज होता है, यूपीआई, राइट, यूनिफाइड पेमेंट्स इंटरफेस। हम यूपीआई को यूज करते हैं ट्रांजैक्शन करने के लिए, राइट? तो अब 6 पार्टीज इन्वॉल्व हो गई इस एक छोटे ट्रांजैक्शन में। बिटकॉइन में कितने लोग इन्वॉल्व होते होंगे? केवल 2। यू नीड 2 पार्टीज, मी एंड देवांश. I can transfer value to Devansh without having any other party involved in this transaction. Now, how does this happen? How do we make sure कि मैंने जो अगर 0.1 BTC देवांश को भेजा है वो एक्चुअल में भेजा है या सिर्फ एक मजाक नहीं किया है? Well, that happens. I think there's someone raising their hand. Okay. Okay. तो ये कैसे होता है ये हम आगे समझेंगे कि एक नेटवर्क, एक फाइनेंशियल करेंसी कैसे रन होती है विदाउट हैविंग एनी फाइनेंशियल इंटरमीडियरी। दैट हैपेंस विद द हेल्प ऑफ ब्लॉकचेन दैट वी हैव लर्न्ड, राइट? अब बिटकॉइन समझ गया, बिटकॉइन इज द फॉर्म ऑफ डिजिटल करेंसी, डिजिटल ऐसी करेंसी जिसका कोई सेंट्रल मालिक नहीं है, सब इसके मालिक है, सबका मालिक एक है, ऑल ऑफ दैट सॉर्ट ऑफ थिंग। अब इथीरियम क्या है? वेल, बिटकॉइन को बनाया गया था एक डिजिटल फॉर्म ऑफ करेंसी के तौर पर, एक वैल्यू के तौर पर। इथीरियम थोड़ा अलग है। इथीरियम इज अ मोर जनरल पर्पस ब्लॉकचेन। मतलब क्या? ये एक बेसलाइन टेक्नोलॉजी है जिसके ऊपर हम और कुछ बना सकते हैं, राइट? इट्स अ डिसेंट्रलाइज्ड ब्लॉकचेन जस्ट लाइक हाउ बिटकॉइन वाज बिल्ट, बट इथीरियम में थोड़ा एक्स्ट्रा चीजें हैं। जैसे इथीरियम में 2 चीजें जो यहाँ पे दिख रही है आपको, ईवीएम यानी इथीरियम वर्चुअल मशीन, और स्मार्ट कॉन्ट्रैक्ट्स। ये ईवीएम मतलब आपने वो सैंडबॉक्स का नाम सुना है? सैंडबॉक्स जो आप यूज करते हो, सैंडबॉक्स मोड में किसी ऐप को आप रन करते हो, वो किस लिए यूज होता है कि अगर कोई पुराना वर्जन है ऐप का जो आपके नए ऑपरेटिंग सिस्टम में कंपैटिबल नहीं है, तो आप उसको सैंडबॉक्स मोड में चलाते हो, मतलब रन इन कंपैटिबिलिटी मोड में चलाते हो। विंडोज में होता है ये ऑप्शन। सिमिलरली ये जो ईवीएम है, ये किसी भी दुनिया के किसी भी कंप्यूटर पे अगर मुझे इथीरियम या इथीरियम बेस्ड प्रोग्राम्स चलाने हैं, तो ये सैंडबॉक्स की तरह एक्ट करता है ईवीएम। और स्मार्ट कॉन्ट्रैक्ट क्या है? स्मार्ट कॉन्ट्रैक्ट उसके अंदर का एग्जीक्यूटेबल कोड है, राइट? ये एवीएम एक सैंडबॉक्स हो गया, और सैंडबॉक्स के अंदर चलने वाले कोड को हम स्मार्ट कॉन्ट्रैक्ट बोलते हैं। नाउ ये स्मार्ट कॉन्ट्रैक्ट मुझे क्या पावर देता है? मुझे स्मार्ट कॉन्ट्रैक्ट को अगर समझना है, इफ आई हैव टू अंडरस्टैंड स्मार्ट कॉन्ट्रैक्ट इन दैट वे, अगर उसको समझना है तो बहुत आसान है। कॉन्ट्रैक्ट्स क्या होते हैं? अग्रीमेंट्स होते हैं, वर्बल अग्रीमेंट्स को हम पेपर पे लिखते हैं और उसको फॉलो करना पड़ता है क्योंकि वो एक लीगल डॉक्यूमेंट पे लिखा होता है। जैसे अगर एक देवांश मेरा घर बना रहा है, देवांश बिल्डर है और देवांश मेरा घर बना रहा है, तो अब अगर मुझे ये मेक श्योर करना है कि देवांश मेरा घर बनाएगा और मेरा पैसा लेके भाग नहीं जाएगा, मैं एक 100 रुपए का स्टैम्प पेपर लाऊंगा और उस पर लिखूंगा कि भाई देवांश, अगर तूने इस तारीख तक मेरा घर बनाया तो मैं तेरे को 1 करोड़ दूंगा, ठीक है? मैं बड़ा बंगला बना रहा हूँ मैं, तो आई हैव मनी। So we both agree to the contract. We sign the contract, and Devansh completes the construction of my house. I'm satisfied. I pay the amount to Devansh. Deal done. ये होता है कॉन्ट्रैक्ट रियल लाइफ में. अब स्मार्ट कॉन्ट्रैक्ट क्या होता है? नाउ अगर मैं बोल रहा हूं कि देवांश को मेरे लिए ये ट्रांजैक्शन करना है, या देवांश को मेरे लिए पर्टिकुलर ये एक चीज बनानी है, जैसे मैंने एक वीडियो एडिटिंग का जॉब उसको दिया है, ठीक है ना. अगर मैं एक स्मार्ट कॉन्ट्रैक्ट में इसी कॉन्ट्रैक्ट को एक नॉर्मल रियल लाइफ कॉन्ट्रैक्ट को डालता हूं, तो ये इफ देन स्टेटमेंट बन जाता है. मतलब इफ एक्शन ए हैपेंस देन डू एक्शन बी. मतलब इफ देवांश एडिट्स माय वीडियो देन गिव देवांश 1000 रुपीज, राइट. ऐसा मैंने एक स्मार्ट कॉन्ट्रैक्ट बनाया और उसको इथीरियम के वर्चुअल मशीन में डाल दिया. अब ब्लॉकचेन 101 में आपने सीखा होगा कि ब्लॉकचेन पे रिकॉर्ड किया डेटा इज इम्यूटेबल, मींस इट कैन नॉट बी ऑल्टर्ड, इट कैन नॉट बी चेंज्ड. अब वो कैसे होता है वो भी हम आगे डेमोन्स्ट्रेशन में पढ़ेंगे, बट इसेंशियली आपको इतना समझने की जरूरत है कि बिकॉज दिस डेटा कैन नॉट बी ऑल्टर्ड, दिस स्मार्ट कॉन्ट्रैक्ट कैन ऑल्सो नॉट बी ऑल्टर्ड. मतलब जब तक देवांश मेरा वीडियो एडिट करके सबमिट नहीं पुश करता, तब तक उसको उसका पैसा मिलेगा ही नहीं, राइट. दिस इज स्मार्ट कॉन्ट्रैक्ट. ना अब ये जो इफ देन वाला जो एक्सप्लेनेशन है ये काफी रूडिमेंट्री है, मैंने काफी डम डाउन करके आपको समझाया है ताकि ये आसानी से दिमाग में समझे. लेकिन इन्हीं स्मार्ट कॉन्ट्रैक्ट्स की मदद से मैं डिसेंट्रलाइज्ड एप्स बना सकता हूँ, डैप्स बना सकता हूँ, राइट. व्हाट आर दीज डिसेंट्रलाइज्ड एप्स? वेल, डिसेंट्रलाइज्ड एप्स वो है जिसमें एक ट्रेडिशनल ऐप के डेटाबेस सेक्शन को रिप्लेस करके मैं एक स्मार्ट कॉन्ट्रैक्ट को यूज कर रहा हूँ. एक ट्रेडिशनल ऐप में या वेबसाइट में एक फ्रंट एंड होता है, एक बैक एंड होता है और एक डेटाबेस होता है. तो अगर मैं उस डेटाबेस को हटा दूं और एक स्मार्ट कॉन्ट्रैक्ट या एक ब्लॉकचेन को वहां लगा दूं, तो जिस तरीके से उस ऐप पे ट्रांजैक्शन, हर ऐप एक ट्रांजैक्शन होता है, राइट. जब भी आप किसी वेबसाइट पे जाते हो, कोई इन्फॉर्मेशन सर्च करते हो, तो आप इन्फॉर्मेशन सर्च की रिक्वेस्ट सर्वर को भेजते हो, सर्वर वो इन्फॉर्मेशन सर्च करता है और वो रिक्वेस्ट आपको रिटर्न आती है, राइट. दिस इज अ ट्रांजैक्शन. यू सेंड अ रिक्वेस्ट एंड यू गेट आंसर बैक. That is usually what happens in a traditional like a website. You ask for a particular information, you get that particular information. Now, what if I have these transactions happening on chain in a way that, oh, sorry, I lost the track. I read something in the chat and I lost the track. Yeah. In a decentralized app, when I replace the traditional database, this traditional request, this traditional transaction of a database with a blockchain, with a smart contract, what happens is this process becomes decentralized. Means now no one central server, no central machine has the absolute power or control of the data that is being generated by the users on this network. That's essentially what you have to understand about this. Now, how do these transactions happen and what's the exact differentiation between a Bitcoin and an Ethereum stack? Here on the hardware level and on the peer-to-peer network and operating system level, at least, they are completely similar. Bitcoin and Ethereum are very, very similar. In fact, both of these blockchains have been made in a very similar way. Both of them used to be proof of work-based blockchains. What is that? I'm going to cover in a later stage. Now, Ethereum is a proof of stake-based blockchain and Bitcoin is a proof of work-based blockchain, right? Bitcoin is a level 1 blockchain which operates on a blockchain protocol. Ethereum has Ethereum virtual machines. जैसे मैंने आपको समझाया था, the difference between these two. And then with Bitcoin, it's very limited. Only value transfer is possible. But with Ethereum, there's a lot more applications which have given rise to a lot in the Web3 space. Now, what is a consensus mechanism and why is it needed? So we've understood what, first let's understand what is a consensus mechanism. To understand a consensus mechanism, we have to understand that it's a technique by which you can have trust in your network. Now, in a traditional system, in a centralized system, you don't need this because you have a central authority that you trust. When I'm dealing in Indian rupees, I have the Indian government that makes sure that I don't screw around. My money is real. If I have a 100 rupee note in my hand, that note is real because the governor has signed on it. I trust central bank, right? I trust the Reserve Bank of India. I trust the central government, so that that's the reason I do not need a trust in my system, because that is being taken care of by another authority. Now, in a decentralized system, I do not have a central authority to control stuff. Now, how do I make sure that in a decentralized system where nobody is king, nobody is the central ruler, trust is maintained in a system, consensus is maintained in a system? That's where we need a machine to bring artificial or argumentative consensus in a transaction. So how do we do that? There are various ways to do this. Right, here are a few popular ways in which how transaction create trust. So some of the most popular ones are proof of work, proof of stake, delegated proof of stake, round robin, federated consensus, PBFT. Very fancy terms. We don't need to understand every one of it. I'm going to cover three which are easy to understand and easy to pick up, and then I'm also going to share like a few examples and share a few resources with you that you can use to maybe further your knowledge if you want to, if you're interested in. So these are the three that we are going to talk about today. These are the most popular ones yet, and there are others also. So there are about 8 to 10 that are used by genuine traditional cryptocurrencies in the market, and there are like every day there comes like a new traditional consensus mechanism that is being added. Every day there's a new iteration of it. So trust me, it's a rabbit hole to get into consensus. If you want to stay away from that rabbit hole, just stick to these three for now. Understand these, and then maybe slowly increase your tolerance to consensus. But let's understand from the first one, proof of work. This was the first one that came up with Bitcoin. In fact, before Bitcoin, proof of work was an idea. And proof of work is what gave Satoshi the idea to kind of start working on a decentralized currency. Now, what is the proof of work? Now, as it's read on the slide, it's a decentralized consensus mechanism that requires the members of a network to expand effort. So the way we build trust in the system is by using effort, right? So what do I mean by that? So I'll have to explain this in how the transaction works on a blockchain, right? How does it happen? In proof of work, there is something called as mining that happens. Now, what is this mining? Let's understand this with this example. So we have two people here, Rob and Laura. Rob wants to send 0.3 Bitcoin to his friend, Laura. Now, the Bitcoin blockchain and a lot of other traditional blockchains are built on this consensus mechanism called as proof of work. Now, what happens in a proof of work? I scan the QR code, I fill the amount, I pay the gas fees and hit send. Now, on the machine end of this transaction, the transaction is signed by my private key, okay? And then the transaction is propagated to the entire network. So if there are like 100 nodes on that network, all 100 nodes get the news that this transaction has happened. Rob has initiated 0.3 BTC to his friend sitting somewhere else in the world. This news of this transaction is propagated throughout the network. Now, before this transaction gets validated, this transaction sits in a pool of incomplete transactions called as memory pool. Now, miners fight amongst themselves. They put effort to make sure that their block is used to mine the next transaction. Now, what do I mean by that? Now, all these miners are given a complicated mathematical problem to solve. Okay, a very complex mathematical problem to solve. This mathematical problem needs your computer's GPU to get solved. Okay, you need a powerful GPU to solve this problem. It makes use of your graphical processing power of your computer to solve this mathematical problem. Now, whichever computer solves this problem the fastest, that computer's nodes or that computer's node is used to mine the next transaction. That computer's block is selected. It was this person. This person has put the most efforts and come up with the solution the fastest. So this guy gets to block the mine. Or block the next transaction. Now, what does the miner get for this? Every time a miner's block is used to mine the transaction, that miner receives a certain reward for mining. So, for example, if he facilitated this 0.3 BTC transaction, he'll also get 0.00001 BTC as a reward for doing this transaction. He gets a bakshish, as they call it in Hindi, right? So, because of which there is an incentive to put efforts. So proof of work is where you put efforts into the system by solving these complex mathematical problems, right? And for the reward of your efforts, you get some Bitcoin as a reward. And this is how a transaction also happens. So once this mining is done, you get the miner who has won. And now this miner solves this and adds the next transaction. The node is verified and Laura sees the confirmation and then the new node appears. That's how a transaction works. Now this process typically takes 8 to 10 minutes. When blockchain started, when Bitcoin started, this process used to take about 30 seconds to 1 minute. But as the number of nodes grew and the number of people interested in mining Bitcoin grew, the transaction becomes harder and harder. There are a few obvious problems with proof of work. The number one is the fact that sorry, it actually uses computational power to solve a mathematical problem. Now, as you know, कि भैया GPU is one of the most energy intensive unit of your entire CPU. So the most energy, if some device requires in your entire computer, is the GPU, because it's one of the most power hungry electronic chip on your PC. Now, because of this, and to get the chance ki your block will be used to mine the next transaction, people have stacked like thousands of GPUs in big factories called as mining pools or mining houses, where people have stacked thousands of GPUs at one place to mine Bitcoin on a day-to-day basis, which has enormous energy requirement. So that, according to one study, I think in 2017 or something, Bitcoin mining used more electricity than the entire country of Denmark used in 1 year. So, which made Bitcoin, see, the whole point of this new wave of digital currency and the new form of decentralized currency is the fact that it tackles the issues of the centralized financial system. And if it creates climate problem, it also becomes a huge problem. The general public would not accept this. So now they needed to come up with a solution where energy requirement of cryptocurrency goes down. And for that particular reason, they came up with proof of stake. Okay, now what is proof of stake? It's another consensus mechanism where blockchain confirms the transactions and prevents the problem of double counting. Right? The whole point of this staking and everything is to make sure that double counting does not happen. What do I mean by that? Consider this as a singular unique piece. I have this note. Just assume that it's a note. It's not, but just assume that it's a note. Now I say this is a 100 rupee note. I keep it down. I bring this up again, and I say this is the second 100 rupee note. Right? How do I make sure that I don't count the same piece of cloth as 100 rupee note? If इसको मैं एक बार देख लूंगा, इस पे tick mark मार दूंगा, and I prove कि boss this is not this is not duplicated, just to make sure that I don't use the same 100 rupee to send money to Devansh and to Yash. So that's the whole point of consensus on a chain. So whereas POW uses like cryptographic puzzles or mathematical problems, proof of stake requires validators on its network, right? So how does it happen? Now, validating capacity depends on the stake in the network, right? Mining depends on computational power. Validating depends on stake in the network. So how many tokens I own? For example, on the Ethereum chain right now, if I own 32 ethers, I am eligible to become a validator. So what do I have to do to become a validator on a proof of stake? Essentially, if I have 32 ether, I have to stake my ether back to the network. Means if I have those coins, I have to give those 32, take those 32 ether, lock them in a vault, and give it back to the Ethereum network, showing that I am committed to validate transactions on chain, right? They do not receive a block reward. Instead, they collect transaction fee on every transaction as reward. So now we use an algorithm to choose. If I have, say, 100 people with 32 ether ready to become validators, now I have a algorithm which decides on random basis which particular person of these 100 people will validate the next block. Now this randomization obviously depends on kitna zyada mere paas coins hai. So if I have more than 32 ether, say I have 100 ether, I'm very rich, and I've staked all of my 100 ether, that shows that I'm ready to validate more. Okay, which means my chances of getting the next block is also high. Or what if sorry, just a second. What happened? Oh, okay. Also, so for example, if I have staked for too long, so for example, I put my 100 ether 2 years ago, and Devansh put his 32 ether yesterday. So I have more experience on the network. I am veteran. So my block will be essentially used to mine the next transaction. In this way, it's almost randomized, but not completely randomized. This reduces significantly, because now you don't need to solve that cryptographic puzzle. to mine the next block. So that entire usage of GPU is obsolete. You don't need GPU to mine the next transaction. So the computational use or the computational power required per transaction is reduced by up to 98%. Right? This has significantly reduced how we essentially validate transactions on chain. And this was a big event, by the way. If you guys have not seen this, I'll show you quickly what I mean by that. Can we escape this? Hold on. Yeah, I'll show you Ethereum merge. So can you see my screen, Devansh? Can you see the Ethereum merge? Okay, so this was the big event that happened on like I think a month ago. This was the merge. So Ethereum, as you know, is the world's second most popular blockchain, and this thing did an incredibly like first time in like history sort of a thing live. So what they did essentially, they updated the Ethereum software system. Just to dumb it down for everyone who don't understand this, they upgraded the entire software ecosystem of Ethereum without shutting it down. Whenever we update our Windows laptops, we install the update and then it asks us to restart, right? Because it literally has to shut down and start every process from the start. That's how update is completed. But Ethereum did this without ever shutting down. So I think Cash from Solana gave a very beautiful example to explain this. It was like you are running two cars in parallel, right? You change the engine of one car from the other car without ever shutting down this car, and the car still is running at top speed. Means while Ethereum changed its entire consensus mechanism, it never shut down. No transaction was ever stopped. Such a monument. And plus, if this was done by a corporation, like where 1,000 employees were put into a factory and they're asked to do this as their job for the entire duration, that would have been acceptable. But all of this was done by open source contribution by people sitting everywhere across the world. Was a monumental achievement for open source development A, Web3 2, and Ethereum third. So anyone who has doubts ki an entire community of people coming onto consensus cannot do anything, this is a big clap to their face, because Ethereum merge was a significant achievement in that particular regard. So all the open source contributors in the chat show some love, because this is something that nobody would ever imagine of doing. If you do want to read, this is exactly what happened, right? So we had a proof of work based chain which used to that was the old Ethereum that used to validate transaction using POW, just like Bitcoin does right now. And then they had a beacon chain, a parallel chain running parallelly to the Ethereum's already existing chain that used to run on proof of stake. And now they stopped the proof of work and started the proof of stake as the main chain and continued without ever stopping the Ethereum network. Cool achievement, cool feat. But yeah, that's exactly what I want to cover. Sorry. So I hope you understood proof of work and proof of stake. Now, hacking also becomes slightly difficult on proof of stake, because essentially to hack the entire network, you will need to have control of 51% of the entire cryptocurrency of that network, which is practically impossible for this entire network of cryptocurrency. But again, it's possible in smaller blockchain, but it's not possible on large scale blockchains like Ethereum and like Bitcoin. But yeah, that's a different point. One way where proof of stake is kind of behind is where proof of stake essentially incentivizes the richer people. So if I have more money, I can simply buy more Ethereum and stake it to increase my chances of earning more from it. Right. So it does not give an opportunity to everyone who is, who wants to become a validator to become a validator. There's a pay gap, or there's a pay wall essentially, that I need to have 32 Ether to be able to become a validator. Now it has its pros and cons, but one way we can solve it is by democratizing the process. Right. Now, how do we do that? This is the third thing that I wanted to cover, is delegated proof of stake. Now, what is delegated proof of stake? It's like POS. It was developed by Daniel Larimer, and it is just like proof of stake, but instead of doing it in the hard code way, it does it in a more democratized fashion. Now, what do I mean by that? Some people amongst the network basically volunteer to become delegates. Okay, so just like how staking may you have validators, you have delegates. Okay, and all the rest of the network participants, based on how many coins or tokens they own on a network, get to choose which one of these delegates will validate transaction. Imagine this working exactly like a parliamentary democracy. So if I want to bring a change in the society, I can't simply go and form a government and do this, because I don't have alone me don't have a power, right? What will I have to do? I'll have to sign myself for an election. Say for example, the legislative assembly elections for Maharashtra, which is where I come from, and then I'll sit in the election. People will vote for me. If I get elected, or my party gets elected and comes to power, I will go in the parliament and take the issues of my people and vote on the important bills. So instead of everyone voting on the transaction, we choose certain individuals from the nodes and decide that these people are going to be essentially uh, validating transactions for me. Now, there are pros and cons to this, but the biggest advantage in this is that if someone misbehaves, so every validator, every delegate obviously has to stake their token. So if I have to become a validator on this particular blockchain, I have to stake my token to become a delegate. Now, if I behave incorrectly, if I do fake transaction or do bad behavior on the network, my staked currency is confiscated by the network. I am punished for being a bad validator, right? And in this way, I'm quickly replaced by a good behaving delegate. So it's a very free and fair and democratic way of choosing a validator on a network. In a proof of stake based like system like Ethereum, it does not have the power simply right now, where everyone of the network can get the right to decide. But in DPoS, you get the choice to do so. Got it? So yeah, this is the theoretical part of this. Now let's understand blockchain fundamentals from a very basic level, and then we'll open this round to questioning, because I think बहुत ज़्यादा ज्ञान हो गया. But yeah, so if I have to explain you what a block means and what a hash means, this is how you can understand it. So this is a SHA-256 algorithm. मैंने hash का काफी नाम लिया. Throughout my presentation, I've taken hash multiple times. So what does it mean exactly? Consider hash like a digital fingerprint of any data that you put on the blockchain. Okay, so right now you see there is this big box with data on it, and there is a hash that starts with E3 BOC. Now this is a 256-bit hash of zeros and ones converted into hex code. So that's why you see this number. Okay, now if I have to understand, this is the hash that is the fingerprint for this blank data. Now look what happens when I just type my name, right? This is Nikhil. So my hash now starts with D61D. Cool. Now if I delete this and write Nikhil again, my data still starts with D61B. So essentially this is the same hash, right? So what do I mean by a hash? Hash is the digital fingerprint of any data. So if I write Nikhil, then this 256-bit of hash is the representation of that data on the chain. Understood this much? Now, what is a blockchain? Let's understand what is a blockchain. Now, let's understand what is a block. Now, block is similar to what I said. It's like a digital fingerprint of the transaction only. Now, we've just distributed this block into a few more data points. Now, you see there is a block number. This is just a serial number like 1, 2, 3, 4. There is a non, which we'll come back to, and there is data part, and then there is a hash. Okay. Now, this blank data is starting with 4 zeros. Okay. Now, if I write anything, for example, hi, see this data. Now this has gone dark. This has gone red. And the data you see here, the hash you see here is 8043C, right? If I delete this again, you see this hash has something special about it. It starts with 4 zeros, right? This is a special kind of hash. This is what happens in a standard hashing algorithm, 256 hash, that every bit of data is represented by a hash that starts with 4 zeros. Cool. That's what you need to understand. Now, if I change this data, if I type hi, this hash has changed. Now, how do I make sure? How do I come back to this possibility that I have that hash that starts with 4 zeros that is corresponding to the data that I've written? So I change this number. This number, non, stands for number generated only once. Okay, so if I type 1, 2, 3, 4. So if I type 4, I have 1, 0. Okay. So this is essentially counting. We studied this in permutation and combination, counting like transactions. So this is exactly that. Now, how many times do I have to count to make sure that I have a data that I have a hash that starts with 4 zeros and that is corresponding to this? That is essentially what mining is. This is the mathematical problem that we are trying to solve. In a SHA-256 algorithm, this is the math problem that we are going to solve. Now, if I mine this, so I have to count 28,605 times to get a hash that starts with 4 zeros that is corresponding to the data I that I've written in the block. Cool. This is the mathematical problem that we usually solve in. So now let's understand what is a blockchain. Now a blockchain is it's an interconnected network. So I told you, right, every block is connected to its previous block. How do I know that? See, the first hash is 1578, 4 zeros in 1578. And what is the previous hash address that is written here? 4 zeros and 1578. What is the hash here? 125A, sorry, 12FA. And what is the previous hash here? 12FA. So every hash is connected to its previous block in this fashion. Now, what happens if I write something on block number 4? Anything I write, this hash changes, right? And this hash changes. Now, if I have to add something, I'll have to mine this, and I have to mine this. Make sure that both of these are again on the chain. So that's why manipulation of data is difficult on a blockchain. The only way, if I change the data, sorry, I'll just quickly mine this back again. So when I say that data on a blockchain is immutable, what do I mean by that? Now, if I have to alter this blockchain, again, if I write something on block number 2, now these 3 blocks are out of sync because they do no longer have a connection with their previous blocks. I'll have to individually mine the blocks from block number 2 up until the last block, whichever has been mined. Now, यहाँ पे तो सिर्फ 5 blocks है. In a traditional blockchain, there will be thousands of blocks. So if I alter data in even one of the blockchains, I'll have to mine all the 1,000 blocks again, which is simply, nobody in the entire world has simply this much computational power to mine this transaction again, right? That's why it's practically impossible to alter data on a blockchain. So the only way we can add new information on a blockchain would be to change this particular block, because now it does not disturb any previous block. It stays the same. And if I mine this, now it is on the chain, it's validated by all the 5 blocks, and it does not disturb the blockchain. Now you would say, okay, this is still a private blockchain, right? This is still a single blockchain. I could change a few datas here. I could mine this. How does this happen in a traditional blockchain, where this is where a peer-to-peer distribution comes in? So now, just like I had those 5 blocks, I had that information. What if that information is also shared with multiple people? So on a traditional blockchain like Bitcoin, if we have 5 blocks on Bitcoin, I'll have the data of those all 5 blocks. Devansh will have the data of all those 5 blocks, and everybody on the Bitcoin network who's validating will also have the data of those 5 blocks. So if I change something on my particular blockchain, so for example, I'll change something here, okay, and I mine this. Look at my hash here. It starts with 3885, but on the other blocks, it does not start with 3885. It starts with E4B9, or it starts here with, so if I go on the peer 3, it starts with E4B9, which means that if I have to alter data on the blockchain, I'd not just have to hack my own blockchain record, but I'll have to hack every peer that exists on the planet. That's again the second reason why changing or altering information on a blockchain is practically impossible. Even if we have computational power worth to change an entire blockchain, it will still be only on one system and not on the entire peer list, right? That's why it's practically impossible. That's why so many people, when they ask question, but what if I do this? What if I do this fake transaction? It only happens on your node. You won't be able to change the entire peer list. And that's the whole reason why it's so difficult for us to alter data or fake data or have fake transactions on chain. So I hope you guys have understood with this demonstration. I'm going to share the link of this particular website because this is absolutely fascinating to study. So I'm going to share this in the chat. Oops, sorry. Yeah, I've shared the link with everyone. Everyone can check this out. And if you want, you can obviously ask questions now. Now that I've covered a lot of theory, and I know some of this theory thoda sa sar ke upar se ja sakti hai because this is new, this is slightly complicated. So if you guys have any questions related to this, obviously go ahead and ask me questions. You can put it in the chat, you can raise your hand, and I'll quickly give you speaking access and you can ask the question. Yeah. Yeah. Exactly. Okay. Okay, Piyush is asking how peer-to-peer network work. Now, I have explained in one way how peer-to-peer network works. Okay. Thank you, Yash. Thank you, thank you. Okay, so peer-to-peer network works on a simple funda. जो हमने आज consensus पढ़ा है, that is how I'll have to explain this in a way where you can't trust the central system to control the entire network. So you can't trust a bank, you can't trust an organization to. So when there is a trustless system, there a peer-to-peer network is required, and how it runs is essentially giving power into. So whenever I am a peer on a blockchain, I have the entire record of the blockchain on my system, and so does everybody on the network. So agar iska main example do, there is a website called, एक second, I'll show you guys what I mean by that. Let's take the example of Ethereum and let's understand in that way. Okay, so you see this is Etherscan. Okay, now Etherscan is a record of all transactions. Sorry, yeah, Etherscan is a record of all transactions happening on the Ethereum blockchain all throughout the world. So this much information, whenever you start an EVM on your system, as per se, all of this information of a particular block is also loaded onto your system. When you become a validator, all of this information is also added on the system. That's why we have multiple peers. Peers are essentially those nodes with every information on their system, right? Whenever you become a validator, that's what gets added on the system. एग्जैक्टली सो अभी ये जो माइनिंग होती है, प्रूफ ऑफ वर्क बेस्ड सिस्टम में जो माइनिंग होती है, उसमें माइनर माइन करता है और वो बताता है कि भाई ये ट्रांजैक्शन है, ही रिकॉर्ड्स इट ऑन द ब्लॉक and that block is added to the blockchain. So a new block is added to the blockchain, and every validator now has to agree with it. Every validator agrees कि yes, this was added by a legitimate miner, or in the case of proof of stake, this was validated by a legitimate validator who has 32 ether and has good intentions, and this person has added this transaction, so we agree with it, right? Every validator agrees with it, and then only this transaction is added onto a blockchain. So जैसे मैंने जो पूरा ट्रांजैक्शन का साइकिल समझाया था बिटकॉइन में कि एक बंदा अपना क्यूआर स्कैन करता है, then he goes through the entire process, mining happens in the background. Once the mining is done, it gets added. What do I mean by that added? ये देखो यहाँ पे what does mean? I think visual representation of how a transaction gets added is much more powerful. Sometimes it kind of gets lost in the complicated words. So Ethereum और बिटकॉइन को विजुअलाइज करना चाहूँ कैसे होते हैं इसके ट्रांजैक्शन, इस तरीके से. तो देखो ये ब्लॉक्स है, ऑल ऑफ दीज इंडिविजुअल पीपल कमिंग टू दिस, ये जो बोर्ड पे आ रहे हैं, ये सारे इंडिविजुअल लोग अलग अलग ट्रांजैक्शन है. अगर मैं किसी भी एक इंसान पे क्लिक करूंगा ना, तो यू कैन सी ऑल ऑफ दिस इज अ ट्रांजैक्शन. यू कैन लिटरली सी कौन सा वॉलेट एड्रेस से किस वॉलेट एड्रेस पे पैसा जा रहा है, कितना मैक्स गैस फी जाने वाली है, कितनी प्रायोरिटी गैस फी उसने पे की है, और गैस लिमिट क्या है, राइट? तो ये सारी इंफॉर्मेशन के साथ वो एक ट्रांजैक्शन एक ब्लॉक में लोड होता है. और ये जो बंदा खड़ा है यहाँ पे, दिस इज अ वैलिडेटर. आई कांट क्लिक ऑन दैट वैलिडेटर फॉर नाउ, बट हाँ, जो बंदा वहां पे खड़ा होता है दैट इज अ वैलिडेटर, वो आपके टीटी की तरह काम करता है, जो बस में टिकट नहीं चेक करता, वो बस देखता है कि हाँ ये ट्रांजैक्शन बराबर है, दिस ट्रांजैक्शन इज करेक्ट, सो या यू आर अलाउड टू गो इन द नेक्स्ट ब्लॉक, राइट? दैट इज व्हाट इज हैपनिंग इन इथेरियम. ऑन द अदर हैंड इन बिटकॉइन यू सी, और हाँ ये जो है ये इंटरेस्टिंग है, ये जो लोग आपको दिख रहे हैं लाइन में, ये लो फी वाले लोग, दिस इज अ मेमोरी पूल. So all of the transactions that are that do not have the required gas fee or incomplete still, all of these transactions are waiting inside a memory pool or mempool for short, right? So अगर आपको imagine करना है कि एक इथेरियम पे ट्रांजैक्शन होता कैसे, या एक बिटकॉइन नेटवर्क पे ट्रांजैक्शन होता कैसे, आप इस तरीके से इमेजिन कर सकते हो. Can I mine all blocks at a time? You can't, right? You only, so जब आप essentially आप माइन करते हो, मतलब आप क्या करते हो कि आप सॉल्व करके उस इथेरियम के या उस बिटकॉइन की चेन पे आप एक नया ब्लॉक ऐड करते हो, राइट? एक ट्रांजैक्शन के साथ एक नया इंफॉर्मेशन अटैच करते हो उस एग्जिस्टिंग चेन पे. दैट इज व्हाट यू आर डूइंग. सो कैन यू माइन ऑल द ब्लॉक? यू कांट. Nobody has the computational power to do so, if that makes sense. Yeah, yeah, not all of them, but yeah, it's one of the most popular ones. Hmm. क्वांटम लेवल कंप्यूटिंग लगती है, क्वांटम कंप्यूटिंग लेवल की पावर लगती है. हाँ, ठीक. So एक बड़ी पॉपुलर सेइंग है that you can build solutions for humans, you can't build solutions for idiots. Now what do I mean by that? So I have not read the entire story of what happened in Polkadot या सोलाना में अभी recently बहुत बड़ा हैक हुआ था. So उसका मतलब क्या है मैं आपको समझाता हूँ. See, on you can protect the entire blockchain with whatever level of algorithms, hashing, cryptography and everything you want to add, whatever layer of security. You can't protect the craziness of a human being. In 2022, the most used password is still QWERTY123 and 1234567, right? So most of these hacks happen on the user end, not at the blockchain end. Most of them. I'm not saying all of them. There are obviously some security flaws with some of the architecture, but 90% of all of these hacks have happened on the user end, where the user have given onto a gone onto a phishing site where they have willingly given access to their wallet by signing a transaction that they should not have signed. Right now, how do you solve a problem for that? Google has tried to solve this by simply eliminating the need of passwords. एक बार डाल दो, अगली बार से वो सीधा OTP भेजता है, right? But how do you do this in crypto? That is a big problem that a lot of companies are trying to solve. I think Arcana has come up with a solution for this. They are trying to build up a solution जहाँ पे वो एक authentication service ही बना रहे हैं for blockchain transaction. But again, this is a most of these problems, most of these acts, and I'm not saying all of them, happen because of user negligence. ठीक है? And obviously, see, some of them जो hacks होते हैं ना, अभी Polkadot पे I think there's a lot of, so in the substrate program, what we are essentially trying to do is establish connection between two blockchains. So आज अगर मेरे पास एक इथीरियम में करेंसी है और मुझे बिटकॉइन में कॉन्वर्सेशन करना है, so it's impossible because these are two entirely different blockchains. Polkadot basically bridging कर रहा है so that I can do seamless transaction between Ethereum and blockchain, Ethereum and Bitcoin without having the need of a swapping ये Uniswap जैसा कोई टूल के बिना अगर मैं कर सकूं तो उसी के लिए ब्रिजिंग हो रही है. Now during this I think there are some concerns that are in the substrate program in itself, but I am not qualified to give a guess on that, but my educated guess is there has to be some way of mitigating this problem and they are already solving it. So I don't think Ethereum has had major security flaws for quite some time now. Some of these user generated things we are obviously going to hear till the time we are dependent on centralized exchanges for हम पे ये प्रॉब्लम होने वाले हैं. हम लोग डिसेंट्रलाइजेशन की बड़ी बड़ी बातें करते हैं and then the only way to get money is using Binance or FTX. हाँ, तो प्रॉब्लम तो होने वाली है. So I don't think that and up until the point we have a solution for that, there's no there's no telling what might happen. Hmm. Okay. I
Recording
think
in
Devansh is back.
progress.
Yes. 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 हाँ. Hmm. 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 Again, I will have to study this exact because I don't know the source of this information. मैंने पढ़ा नहीं है completely. But इतना मैं बताना चाहूंगा कि most of the stuff that MetaMask does at least does locally. तो जो भी क्रिप्टो स्टोर होता है ये होता है वो आपके पर्टिकुलर मेटामास्क नोड पे ही सेव होता है. तो इट्स नॉट अ क्लाउड बेस्ड सिस्टम. मेटामास्क इज नॉट अ क्लाउड बेस्ड सिस्टम कि आप ये कर सकते हो. व्हेनेवर यू रिमेंबर, आई डोंट नो इफ यू नो दिस, जब आप एक सेंट्रलाइज एक्सचेंज पे जैसे बाइनेंस पे अगर आप अकाउंट बनाते हो तो आप डिवाइसेस स्विच करोगे तो आपका क्रिप्टो स्विच हो जाएगा क्योंकि सब क्लाउड पे है. मेटामास्क में ये सिचुएशन नहीं होती है. यू लिटरली हैव टू लाइक ऐड दैट नोड ऑन टू योर मोबाइल एंड तो सेम मेटामास्क ये बनाना थोड़ा पेन होता है, right? Because everything is happening locally. So even if it does collect your information, which you can opt out of, by the way, whenever you sign in on MetaMask, you can literally opt out of telemetry and it doesn't make a difference. So it does locally. But if MetaMask is doing this, I am not sure what to believe anymore. But yeah, this ideally should not happen. And I don't know why there is a need of collecting IP addresses on MetaMask. I would have to read more upon this. But I don't think there's a need to collect IP address for anything on MetaMask, to be honest. And answering the second question, Vitalik's transaction. So, see, I think Vitalik is a more isolated example because Vitalik, first of all, he's a publicly known founder of Ethereum. So उस पे ना लोगों की थोड़ी पैनी नजर होने वाली है कि this guy is what he is doing because obviously a lot depends on his credibility as the founder of Ethereum. Look at the example of SFD, no, Sam Bankman, SBD. Uh, FTX की credibility Sam Bankman के साथ थी. Like how much people trusted SBF because उसकी वजह से FTX का brand था. Like he was literally the largest political contributor to the US government. जो बाइडेन की कैंपेन को सबसे ज्यादा पैसे देने वाला सैम बैंकमैन था, right? So he was credible in the market. But as soon as this scam came, like this rug pull came out, his credibility was lost, and the entire trust in the FTX thing was like lost also. See, they are doing the exact same shady shit that every other exchange on this planet is involved in. So same Binance करता है, same सारी stock trading companies 2008 में करते थे before SEC was behind their ass. वो same चीजें कर रहा है, but वो पकड़ा गया, right? तो इट्स लाइक दैट सेम हर्षद मेहता स्टोरी कि हर्षद मेहता भी वही काम कर रहा था जो बाकी लोग कर रहे थे उसके जमाने में, बट वो पकड़ा गया, right? So that's why in Vitalik's case also people are obviously more like he is more accountable than others because he is the founder of one of the most important blockchains on the planet. तो अगर वो कुछ गलती करता है तो लोग उसको ज्यादा स्क्रूटिनी में रखेंगे, इसलिए उस पर नजर भी ज्यादा रखी जाएगी. So this is bound to happen, but again, the whole point of our like decentralization was there should be a transparency in transaction. Anybody should be able to see what transactions are happening on the network. Ideally, you should not be able to identify कि ये wallet address किसका है. But ये हो रहा है, and I think the more we have KYC and everything in our whole ecosystem, that is going to happen even more. But then we'll also have to come up onto a consensus कि भैया कितना privacy is too much privacy and kitna transparency is too much transparency. So that is a fine line that we have to come up with. हमको समझना है कि वो हमारे लिए कितना जरूरी है. हम्म हम्म 4 और 5 नहीं बोलूंगा, बट या जैसे मैंने प्रूफ ऑफ स्टेक कवर करते हुए भी बताया था कि इट गिव्स पावर इनटू द हैंड्स ऑफ पीपल हु हैव मनी इनफ टू लाइक इनफ मनी टू बाय 32 ईथर्स, राइट। स्टेकिंग का सबसे बड़ा डिसएडवांटेज यही है कि इट काइंड ऑफ, सो वही है ना, विटालिक ने जो डिसेंट्रलाइजेशन का ट्राइलेमा बताया था, ब्लॉकचेन ट्राइलेमा, कि इन ऑर्डर टू मेक अ सक्सेसफुल ब्लॉकचेन यू हैव टू कॉम्प्रोमाइज ऑन वन ऑफ द 3 थिंग्स: डिसेंट्रलाइजेशन, स्केलेबिलिटी एंड सिक्योरिटी, right? So if I now Bitcoin is 100% secure and 100% decentralized. Like, matlab wo it's heavily decentralized and secure, but it's not scalable because the more transactions that happen, proof of work और ज़्यादा energy intensive बनता जाएगा. So it's not scalable. Ethereum used to be like that. So it was decentralized, it was secure, but it was not scalable. So to solve that scalability problem, they got um, proof of stake. But now it is scalable and secure, but it's not decentralized as much anymore because now people with money theoretically can come up and take over. People like Elon Musk can have 100 of his stooges to purchase 32 ethers, stake it on the network, and control the flow of the transactions. Obviously, it's difficult. It's not that easy, and there are multiple. So they are using sharding, and they are going to do a lot of things that prevent this from happening. But on paper, this can happen. This adds a paywall to the entire thing of decentralization. कि बस अगर 32 ईथर है तो बात करो, नहीं तो रहने दो, right? Earlier that was electricity, ki boss, do you have the GPU and the electricity to mine? Now it is money. So now you should have money कि भाई इतना पैसा मेरे पास है, इतना ईथर मेरे पास है स्टेक करने के लिए, तो मैं वैलिडेटर बन सकता हूँ. बट देयर नीड्स टू बी सम फॉर्म ऑफ क्या बोलते हैं, एक्सचेंज होना चाहिए ना, कि मतलब मेरे पास ऐसा क्या है कि आई शुड बी ट्रस्टेड फॉर वैलिडेटिंग ट्रांजैक्शन. So in this case, it's Ether. In the proof of work case, that was electricity and GPU power. In the case of DPoS or delegated proof of stake, it's reputation. कि मैं कितने अच्छे ट्रांजैक्शन कर चुका हूँ. So the more good transaction I do, the more my reputation increases. जैसे ही पॉलिटिशियन का होता है ना, कि जितने अच्छे दिन मैं लाऊंगा उतने लोग मेरे को वोट देते जाएंगे, right? So that is exactly how it works. So there needs to be some form of it, but I think, yeah, staking does bring an aspect of centralization onto blockchain, and it will be interesting to see how Ethereum tackles it. Yeah. Yeah, obviously the answer is always in the middle. Too much extremity is always bad, right? So the answer is always in the middle. And I'm sorry guys if this was like a too doozy session, क्योंकि I know they थोड़ा सा complicated topic है consensus, and अगर ये आपको नींद आ गई हो इसमें तो I'm really sorry about that. I'd obviously try to improve it and make it more interesting the next time. But consensus is a heavy topic to understand, so I apologize if it was too boring. Thanks, Janish. Anywho, I'm going to share the link for the Discord server. I think most of you are part of the Lumos community, but if you are not, Devansh, you can share the link with them, na? Yeah. नहीं तो मैं डाल ही रहा था, but okay, I'll put. हाँ, मैं डाल देता हूँ. Okay, here's the link to the Lumos Metaverse Discord server. So if you have interest in learning more about this, I have an entire DevRel team ready to teach you just this and teach you more about coding and stuff as well. But thank you so much, Sanskruti. Thank you so much, Jalish, for those kind comments. I have one more person, but was 2095 1 ऐसा number में लिखा हुआ है. So thank you to that person as well. And I hope that we can cover more such sessions in the future. Blockchain सीखते रहो. On the server, I'll keep adding resources that you can learn. So I've not added so far. ज़्यादा नहीं किया है मैंने, बस एक channel maintain किया है. But I'll add more and more resources onto our community, and Devansh can share those links with you as well. And you guys can keep learning, keep as a developer, as a student, don't look at the crypto aspect. Although we've talked a lot about this consensus and transactions and everything, your technology is very fascinating, and if you can understand that particular thing and you can build some stuff on it, then it becomes more interesting. That is what we should focus on. Crypto आते जाते रहेंगे. रोज नए क्रिप्टोज बनते हैं, रोज नए रफोल्स बाहर आते हैं, so that is never going to change. But keep building and keep innovating the stuff. So with that, thank you guys. Thank you so much for attending. Sayonara.
Recording stopped.
Thanks, folks. Bye.